Can't hear myself yet. What's this weird? Yeah, it's like two faces in there, kind of thing. There is the mesh. Yeah, the camera is up high. But I have another. Okay, I can see myself now properly. Okay, hello, hello, hello. How are you? Camera is in the ceiling essentially. I don't know why my fingers are jittery like that. They're actually not moving at the moment. But yeah, it's a bit jittery. I don't know why. I don't know if I turn on that light, becomes better or not. Sometimes my head disappears as well. And obviously, there are like essentially two faces. There's this face at the back that has this weird, foxy eyes, mouth, and nose kind of thing. And then there's this thing overlaid on top, which is a bit odd. And sometimes, yeah, the mesh sometimes flickering. It's obviously a separate algorithm thing to move the camera a bit, but or move myself. Anyhow, yeah, especially when I'm looking at the other screen, the mesh face disappears. I should somehow integrate the cap in it. Should be easily detectable as well because it has this nice pattern on it. Okay, let's minimize this quickly. I'll just put it down there at the bottom. As such, ideally it would have been transparent window, but it isn't. So let's continue from where we left off last time. Still stuck on the EG2 music generation. Can't see my mouth, can you? And to be opening my mouth like this. Maybe we should change to the other camera. Last time when I had both of them loaded, I had some issues with the microphone. It's getting a lot of weird noise coming through into the mic. Um, having issues. As a digital twin. But less window a video. So I still have 0, 1, 2, 3. F0. Yeah, that's using the second camera. The one is some sort of virtual camera. Okay, the second camera doesn't work. Doesn't give me any proper error or anything. It's connected to a separate USB port. Right now it's not showing at all. I have another GPT chat. Oh yeah, whatever. Maybe do a 3.5. How to restart this camera without physically reconnecting through terminal in Ubuntu. Yep. This just work? No. Okay, we need to install that. It's just 2 megabytes of stuff. I want to reset this camera. Reset is not available. Determine the kernel model associated with the camera. For model associated with the camera, which may have a name like module name. Okay, what does this mean? Reload the module. Okay, this should restart the camera. No, it did not. I have two cameras connected. The second one is not being recognized. Yep. Yep. Okay, we do have some errors. It's actually a lot of errors. Yeah, getting all this USB device errors. I suspect if I physically unplug, I'll start having trouble with the microphone. Okay, now I have second camera connected. Right, okay, that works. It's just checking that everything is working because I actually unplugged the USB. Let's close this. Let's read this quickly.
ChatGPT. To convert EEG, electroencephalogram, waveforms from a text file into music that can be played in a browser, you will need to follow several steps. Here's a general outline of the process. Extract EEG data. The first step is to extract the EEG waveform data from a text file. This data is typically a series of numerical values representing electrical activity in the brain. Process the EEG data. You might need to process this data to ensure it's in a suitable format for conversion into sound. This could include normalizing the values, filtering out noise, or segmenting the data into manageable parts. Convert EEG data to sound. The next step is to convert these numerical values into sound. This involves mapping EEG data points to audible frequencies. There are different approaches to this, such as directly mapping amplitude to frequency or using the data to modulate synthesized sounds. Generate audio file. Once you have a mapping from EEG data to sound, you can create an audio file. This can be a WAV or MP3 file, for instance. Play the audio in a browser. Finally, to play the generated music in a browser, you would use a web-based audio player. You can either embed an audio player in a web page or use existing online platforms that allow you to upload and play audio files. The actual implementation of this process will require programming skills, likely involving data analysis and web development technologies. If you have the EEG data in a text file and need assistance with any specific step in this process, such as data processing, audio conversion, or web development, please provide more details on the data file, and I can offer more targeted guidance or examples.
Yeah, I'm not sure why it's not very stable. Pop it in there. Okay, that's kind of works okay. I don't know. It's as if my CPU is busy with other things, even though it's set to performance. I'm downloading another dataset from Visionet. That's probably affecting the avatar performance. Let's get back to what we were doing. Close the avatar. We're doing the EEG to music. EEG music. I want to probably start from scratch because what we currently have doesn't really work. Or should we continue? Okay, so we have run BI, we have load data. That is working okay. Let's run this quickly. Play G music. Breaking changes. Yeah, we'll leave the structure for now. Leave the requirements. We have no readme. You want to convert frequencies to nodes. Then convert it to convert the frequency into a specific node. So just printing the musical notes. What? Into a test by instead of listening to the actual frequencies that can be pretty annoying, we want to convert them into musical notes. Yeah, using interpolation functions sounds legit. Solve that one, because yeah. Install it globally as well. Yeah, we are not using any virtual environments. So that error should go away. And replace that prompt with this error. A couple of which adjust the HG frequency range, extend the musical note range. Here's an adjust example using option 1. Yeah, option 1 makes more sense. Yeah, we don't want any super high frequency notes. Scale the G frequencies. Clear that. It's another problem. Normally it means that the JGP doesn't have updated documentation for the code.
I apologize for the confusion in the previous example. The Music21 library doesn't have a direct all pitch names attribute in the pitch class. Instead, we can generate the note frequencies for the entire range of a piano, or any other desired range, using a different approach. Let's revise the code to correctly generate all note names within a specific range and perform the frequency mapping. This script generates all the notes from A0 to C8 and uses their frequencies for the mapping. It also includes scaling of EEG frequencies to match the musical note frequency range. The interp1d function is set with bounds underscore error equals false and fill underscore value equals extrapolate to handle frequencies outside the predefined range, thus avoiding the earlier error. Keep in mind that this conversion from EEG frequencies to musical notes is a creative interpretation, and the resulting music might not have a direct correlation with the original EEG data characteristics.
Okay, so the code is running. What is it doing? Meant to print the musical notes. Okay, we should stop this. Clear the terminal. The code seemed to be running for a long time without producing anything.
The issue with the code taking a long time to run without producing output may be due to the inefficiency in generating all the notes and handling the large array of frequencies. To optimize this, we can use a more direct approach to map EEG frequencies to musical notes. This method involves directly calculating the frequency of each note in the desired range and then performing the mapping.
Okay. Right, so it produced the output. So what if the first frequency is, say, 200? It's a bit odd. It's producing. I thought it would just change that one. It's producing the same thing repeatedly. If I just change one, it changes all of them. Why when I change the first frequency in the EEG example frequencies, it changes all the subsequent notes as well? Not only the first one. Yep.
The behavior you're observing, where changing the first frequency in the EEG frequencies affects all subsequent notes, is due to the scaling factor being recalculated based on the minimum value in the EEG frequencies. This scaling factor is applied to all EEG frequencies, so any change in the EEG frequencies will influence the scaling and, consequently, the mapping to musical notes. Calculates the scaling factor based on the minimum value in EEG underscore frequencies. If this minimum value changes, the scaling factor changes, affecting how all frequencies are scaled up to the musical note range.
Right, so if I change something in between, say this one to 20, it should not change the min max. And then yeah, get them the same. And this one changed from C#3 to C#4. And everything else has remained the same, which is great. Suggesting to fix the issue. I probably don't want to fix it, but let's
fix scaling factor. If you want the relationship between EEG frequencies and musical notes to remain constant regardless of the specific EEG values, you can set a fixed scaling factor. This way, changing one EEG frequency won't affect the scaling of the others. Individual mapping. If you want each EEG frequency to be mapped individually to a musical note, without scaling, you can directly map the EEG frequencies to the musical note frequencies. This approach might lead to many EEG frequencies mapping to the same or very similar notes if they're close in value, given the limited range of musical notes. Dynamic range adjustment. Adjust the range of musical notes dynamically based on the range of the EEG frequencies. This method keeps the proportions relative to the EEG data, but will change the musical range according to the EEG data spread. Let's illustrate the first option, fixed scaling factor, with a revised code snippet.
So does this mean I need the actual frequency for each note? I already have that in the code.
In this version, the scaling factor is fixed based on scaling 1 Hz to the frequency of the lowest note, AO, 27.5 Hz. This way, changes to individual EEG frequencies will alter only their corresponding musical notes, not the entire set.
Now it's probably okay to do the entire set. It's fine. Okay, I want to apply this. Okay, let's do this, the conversion to music. Yeah, I want to put everything into one file. So the loading data, where is it? Static templates, utilities, load data. Okay, I might actually load a smaller set. No, I mean, we want to load this one because it also has seizures in it. Okay, let's start a new file. Call it app. Why? Because that's what it should be called. Yeah, I want this to for sure. From load data, we're using pandas. Okay, that load data is actually working okay. Template. Okay, now this get the G data. It's getting it from somewhere. Why is it doing that again? It is load data. Convert EG to music. Let's write the code. It's taking the code from other files. What happened there? Mid utility. We have the index HTML that looks more or less okay. Let's pop it into ChatGPT, see what it says. Yeah, we don't want fixed.
The script you've provided is part of a Flask web application designed to load EEG data, convert it into music, and potentially serve it through a web interface. Your function convert_EEG_music is currently set up to convert a fixed array of EEG frequencies into musical notes, but it looks like it's intended to work with dynamic EEG data eventually.
Yeah, that's
To
right.
complete your convert_EEG_music function and integrate it with the rest of your application, you need to finish the MIDI file creation. The function currently ends abruptly while setting up a MIDI file. You need to complete the MIDI file creation by adding notes and then saving the file. Integrate EEG data. Replace the example EEG frequencies with actual data from EEG_data. This will likely involve processing the EEG data to extract frequency information suitable for conversion to musical notes. Handle output file path. Decide how you want to handle the output. If output_file_path is not provided, you might want to generate a default path or store the file in memory for immediate playback or download.
Okay, so from this point, print musical notes. Can we just load music 21? Right, where's the get rid of this? Cut load copy. We actually get it from here or and let's pop it into so we have two functions so far. We have this load database there. Yeah, that looks legit. Channel index to list. Returning that. That's okay. I want to take stuff from test. MIDI util. And we have music 21. Did we just install it? But we're not using it anymore.
This function will now create a MIDI file with the converted musical notes and save it to the specified path. If no path is provided, it saves the default output.mid file.
A couple of quick things. Side B, side Y, mid util. We should not need that. Damage generate the whole thing.
Certainly. Let's create the complete convert underscore eeg underscore music function, which will take EEG data, process it to convert the EEG frequencies to musical notes, and then create a MIDI file from these notes. The function will utilize the Music 21 library for music-related operations and the MIDI util library for creating MIDI files. Before you use this function, ensure that both Music 21 and MIDI util are installed in your Python environment. You can install them using pip if they're not already installed.
Okay, this is meant to be a Flask application. Why is it not a Flask application? Okay, we can get rid of that. Get rid of this. That's the wrong folder, isn't it? The main problem. Why is AppPy not running as a Flask application? Well, it needs that code at the end. Needs code at the end. What was our most recent Flask application? The spectrogram. Called spectrogram. Go up by. Need that code. Where does it go? Let's restructure the whole thing. Need to restructure the whole thing. A couple of things. Need to go at the end. Right now it runs as a Flask application. Getting an error. No such file directory. What? Directory issue. Okay, let's see. Index HTML not found. Paste the just in the data folder. Yeah, that's correct. Why do I need those? Okay, where is the HTML? Static. Send templates folder. What's the problem? Question is, Okay, that should have worked. Should be in templates. It's the default. Okay, what? Yeah, we don't need the app folder. Move to trash. Okay, now it's working again. Takes forever to change. This music doesn't do anything. Get that web media deprecated feature used thing. Very easy to music. So if we in this page, theory, we do this. Something should happen. Yeah, let's see. So that's what we
Call the
tried.
function from a root. You can call this function from a Flask root, ideally the one where you handle the conversion process. For example, if you have a root, convert E to music, you can call this function within the root's handler. Run your Flask application. Run your Flask application as you normally would. If you're not familiar with running a Flask app, you usually do it from the command line by setting the environment variable flask_app to your main application file and then calling flask run. Set Flask app variable. In your terminal, navigate to the directory containing your Flask app and set the flask_app environment variable to your main application file name. For example, if your file is named app.py,
Okay. get a 500 error. How to fix? Okay, stop. Let's do the whole thing. What's the problem?
The error message, note, object has no attribute, MIDI, suggests that there's a mistake in how we're trying to use the Music 21 library to convert node names to MIDI node numbers. In Music 21, the correct attribute to get the MIDI number of a node is pitch, MIDI, not just MIDI.
Okay, what was changed by generating the whole thing? If only one thing was changed, just give me that. Note labels. Scan effect.
In this corrected version, the MIDI node number is obtained using pitch, MIDI on the Music 21 node object. This should resolve the error you're encountering. After making this change, try running your Flask application again and accessing the Convert to Music route.
Is that the only change? Okay, we need another. And then obviously we don't want to go to that URL, we want to run everything from the front page.
The error you're encountering is related to the MIDI file add note method, which indicates a missing argument. The add note method of the MIDI file class from the MIDI util library requires specific arguments, including the volume. Let's correct the function call to include all required arguments. The signature for the add note method is typically Here's the corrected part of your convert _eg music function where add note is called.
Already had a volume. Conversion successful. Okay. Where was it saved? There's nothing in music output. Where was the file saved?
The MIDI file was saved to a file named output.mid as indicated by the message save MIDI file to output.mid. The location where this file is saved depends on the working directory of your Flask application where it's running. In a Flask application, the current working directory is typically the directory where you started the Flask server, not necessarily the directory where your Python script resides. So, the output.mid file should be in the directory from which you executed the Flask run command.
Right, it is in the main directory of the whole project. Can't play MIDI files with VLC. That's not cool. Why do I have two VLC MIDI players? Could not decode the format MIDI file. What? And it's MID, not MIDI. Does that matter?
Make sure to replace path to your desired directory with the actual path where you want the file to be saved. This could be a static directory within your project or a user-specified location. Keep in mind that the Flask application needs to have right permissions to the directory where you're trying to save the file. If you're deploying the application on a server, make sure that the service user has the necessary permissions.
Okay, so we have the raw EG and EG raw and music output in music output. We'll understand the context. Yes. Yes, this folder is relative. Convert rest of concept to specified path. We have to have a folder. It's load data. Yep, this can be taken out. And paste the data, music output. And output mid. We're joining all those. It's the music output. Get rid of that. Let's run this again. Just open it in another. And that button doesn't do anything. Conversion successful. Right, we have the file. Surprised. Do we have anything to play it with? Okay, how do we? Guess that's working okay. How to play the file in the browser? Ideally, want to play it in the main page, in the front page of the web application. Yep. So hopefully it will soon appear on the site somehow. I'll serve it via URL and embed the player.
First, ensure that the MIDI file is saved in a directory that is accessible as a static file in your Flask application. For example, if you're saving the file to eeg_music/data/music_output/output.mid, make sure that eeg_music, data, music_output is within your static directory or is declared as a static folder.
Why is this important?
In your main page's HTML, e.g., index, HTML, you can add an HTML5 audio player element. This player can be set up to load the MIDI file. However, it's important to note that not all browsers support playing MIDI files directly in the audio element. You may need to convert the MIDI file to a more widely supported format like MP3 or WAV. Here's an example of how you might set up the audio player in HTML. 3. Embed the player in your main page. Browser support. As mentioned earlier, MIDI files might not be supported directly by all browsers. You may need to convert the MIDI file to a more universally supported format like MP3. This can be done using a library like pydub in Python. Autoplay option. If you want the music to start playing automatically when the page loads, you can add the autoplay attribute to less than audio greater than tag. Keep in mind that some browsers restrict autoplay to improve user experience. This route will serve the MIDI file. Ensure the path in send_static_file is correctly pointing to where your MIDI file is saved.
Wait, so do I need both of them?
If you find that the MIDI file doesn't play due to browser compatibility issues, you may consider converting it to an MP3. Here's a very high-level view of how you might do this in Python. You would then use this MP3 file in a less than audio greater than element instead of the MIDI file. This requires additional dependencies like pydub and might also require ffmpeg or similar tools. Integrating with Flask. Finally, integrate all these steps into your Flask application, ensuring that your HTML templates, static files, and routes are correctly set up to handle the MIDI file and audio playback.
So in HTML. It's a default, it doesn't have an output file path, that's okay. Question is, what actually generates in the front? A MIDI file. Let's ask this question. It shouldn't just. Yeah, GitHub Copilot just wouldn't understand it because it doesn't have all the context, it seems. Hey, we need the HTML. Be in templates, this one.
The The Python code you've provided for your Flask application includes a backend setup to process the EEG data and convert it into a MIDI file. However, this code does not directly involve the front-end generation of a MIDI file. Instead, the front end, in this case, likely a web page rendered by Flask, will interact with the backend to trigger the generation of the MIDI file and then provide a means to play it. Front-end interaction. The user interacts with the front-end, or web page, by, for example, clicking a button or submitting a form. This action sends a request to the backend. Backend processing. Your Flask backend, the Python code, receives this request. It then processes the EEG data and converts it into a MIDI file, as you've set up in the convert_EEG_music function. This file is saved on the server, in a directory specified in your code. Serving the MIDI file. Once the MIDI file is created, the Flask app can serve this file as a static file. This means the file can be accessed via URL. Front-end playback. On the front end, you can have an HTML audio player that loads the MIDI file from the URL provided by the backend. However, as previously mentioned, playing MIDI files directly in browsers can be problematic due to limited support. It's often more reliable to convert the MIDI file to a more widely supported format like MP3. Front-end code. The HTML, JavaScript part of your front-end would include code to handle these interactions, sending requests, receiving responses, updating the audio player source, etc. This part of the code is typically written in HTML, CSS, and JavaScript. If your front-end needs to include an audio player for the MIDI file, you would add HTML code similar to this in your index, HTML or equivalent template.
Yeah, get it all right.
Your HTML template for the EEG to music app looks well structured. It includes a section for playing the EEG-generated music, a canvas for potentially displaying EEG data graphically, selectors for channel and window size, a data slider, and a footer with credits and information. You're also using chart.js for charting and a script for MIDI, web MIDI functionality. Ensure the generated MIDI file is accessible from your Flask server. This might mean saving it to a directory that's accessible via URL. For instance, you might save the MIDI file to a static folder in your Flask application. Uncomment the audio element in your HTML and update the source, src, to point to the location of your MIDI file. Since MIDI files might not be directly supported in all browsers, consider converting it to an audio format like MP3. If you stick with MIDI, ensure that your browser setup or extensions can handle MIDI playback.
Okay. So this, and yes, this pointing to an MP3. We don't want to do a conversion because we might be generating lots of those files as we change the input on the front page. Do should be URL for that file name. Copy relative path. Use this path instead. Yeah, almost correct. It's not in a static folder. Um, does it have to be in static folder? Got music output. Output mid.
ChatGPT, your main JS file for the EEG to music app appears well structured and is designed to handle various functionalities such as fetching EEG data, plotting it using chart, JS, and handling MIDI events with WebMIDI, JS. Let's go through the key parts of your script. Fetching EEG data. The fetch EEG data function is set up to make a request to your Flask backend to retrieve EEG data. This function takes parameters like start, count, and channel to fetch specific segments of the EEG data. Updating and plotting data. The update data function is triggered to update the EEG data display. It retrieves user-selected values from the interface, like channel and window size, fetches the corresponding EEG data, and then calls plot EEG data to update the chart. EEG chart. The plot EEG data function uses chart, JS to plot the EEG data. It either updates an existing chart or creates a new one if it doesn't exist. Convert EEG to music. The convert EEG to music function sends a request to your Flask backend to trigger the conversion of EEG data into music. This function might need modification to handle the specific parameters required by your Flask root. Handling MIDI with WebMIDI. JS. The script sets up WebMIDI, JS, and prints available MIDI input and output devices. It also sets up an example listener for MIDI note on events. Playing MIDI notes. In the DOM content loaded event listener, you set up an event listener for the play MIDI button. However, the current implementation seems to directly play a MIDI note, C4, on the first output device. This might need to be adjusted to actually play the MIDI file generated from EEG data. Integration with the web page. Your script is well prepared to integrate with the HTML structure of your web application. It seems like it's designed to be responsive to user interactions and update the displayed data accordingly. MIDI file playback. If you want to play the MIDI file generated from the EEG data, you will need to either convert it to a more universally supported format, like MP3, and use an HTML audio element, or use a more complex setup to handle MIDI file playback directly in the browser. WebMIDI. JS is more suited for sending and receiving MIDI messages, not for playing MIDI files directly. Adjust play button logic. Modify the logic for the play MIDI button to handle the playback of the generated music file. This might involve either updating the source of an HTML audio element or implementing a more complex MIDI file playback mechanism. Error handling. Enhance error handling in your AJAX requests to provide user feedback in case of failures or issues with data fetching or processing. Testing. Thoroughly test the application to ensure all parts are working together seamlessly, the data fetching, the EEG data visualization, and the music conversion and playback. Overall, your main JS file lays a solid foundation for the interactive features of your EEG to music web application. The main area to focus on now is the actual playback of the converted music, ensuring it aligns with your project's goals and the capabilities of your users' browsers. ChatGPT. Yes, VLC Media Player can play MIDI.mid files. VLC is a versatile media player that supports a wide range of audio and video formats, including MIDI files. However, the quality of MIDI playback in VLC can depend on the sound fonts or synthesizers available on your system, as MIDI files contain musical instructions that are interpreted and played by synthesizer rather than direct audio data. If you find that VLC is not playing MIDI files as expected, you may need to configure it to use a specific sound font. Sound fonts define how the MIDI instructions are translated into actual sounds. Some operating systems may have default sound fonts, but for improved quality, you might consider downloading and configuring a custom sound font for use with VLC or your system's synthesizer. To ensure the best playback experience with MIDI files in VLC, make sure you have the latest version of VLC installed, as it will have the most up-to-date support for various file formats. Correct file path. Make sure the path to the MIDI file in the src attribute of the less than source greater than tag is correct. In a Flask application, static files are typically served from a static directory, and the path should be relative to this directory. If your MIDI file is not in a static directory, you might need to adjust your Flask app to serve it correctly. The path /data/music_output/output.mid suggests a relative path, which might not work as expected in a web environment. Browser compatibility. Be aware that MIDI file support in browsers is not universal. Some browsers may not support playing MIDI files natively in a less than audio greater than element. You can check for support programmatically using JavaScript. Using Flask's URL_var. In Flask, you typically use the URL_ function to generate URLs for static files. If your MIDI file is in a static folder, you should use URL_var, static, filename equals, path, to, file, to ensure the correct URL is generated. For example, check with JavaScript. You can use JavaScript to check if the audio file was loaded successfully. Add an owner event to the less than audio greater than element to handle any loading errors. Server configuration. If the file is not in a static directory, ensure your Flask server is configured to serve files from the desired location. This might involve setting up a custom route to handle requests for these files. Testing. Test the audio playback in different browsers to ensure compatibility. If MIDI playback is not supported, you might consider converting the MIDI file to a more widely supported format like MP3. Check the file path. Ensure that the file path in the src attribute of the less than source greater than tag is correct. Relative paths can sometimes be problematic in web applications. In a Flask app, it's usually best to use the URL_ function to generate URLs for static files. If your file is in a static directory, use something like
Okay, there are a couple of issues. First of all, the output mid file is not being loaded into the player. The player is still just grayed out. Second of all, I want to be able to do everything from the front panel. So it's not clear when is the output mid is being regenerated.
Addressing your issues requires a two-pronged approach, ensuring the MIDI file is loaded correctly into the player and enhancing user interaction to clearly indicate when the output.mid file is being regenerated. Let's tackle these points separately. Correct file path and server configuration. Use Flask's URL_ to generate the correct path if the file is located in a static directory. Example, less than source src equals URL_ static, file name equals music_output/output.mid, type equals audio, MIDI, greater than. Ensure the Flask app is configured to serve files from the location where output.mid is saved. Testing the file path. Try accessing the MIDI file directly via its URL in the browser to ensure it's being served correctly.
How do I do that? Okay, it's downloading it. Windows Media Player would not, VLC would not play it.
Copy and paste this URL into the address bar of your web browser and press enter. If the file is being served correctly, you should see a download prompt or the file should start playing, if your browser supports playing MIDI files directly. As a sanity check, you can also try accessing a known working file, like an image or a different audio file, placed in the same directory. If your MIDI file is not in the static directory and you're serving it via a custom route in Flask, ensure that the route is set up correctly to serve the file. Test this route's URL in the browser in the same way. Remember, the ability to play MIDI files directly in a browser varies depending on the browser and its settings. Some browsers might not support MIDI playback, or may require specific plugins or configurations. If the file loads but does not play, this might be the issue. In such cases, you could consider converting the MIDI file to a more universally supported audio format like MP3 for playback in the browser.
Okay, so the MIDI file is in the correct location. I'm able to download it. For whatever reason, VLC would not play the file. Now, ideally, I would like to play the sounds directly in the HTML as the user changes inputs. So perhaps I should be playing the notes, MIDI notes, directly in the browser. That's why I don't want to convert it into another file format, because the speed might be reduced. Yep. 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 It's big. It's not even recognizing me saying yep.
If you're able to download the MIDI file correctly, but VLC won't play it, the issue might be with the file itself or VLC's MIDI playback capabilities. However, if your primary goal is to play the sound directly in the browser as the user changes inputs, you have a few options. Since you're interested in playing notes dynamically in response to user input, consider using the Web Audio API, a powerful tool for audio processing and synthesis in web applications. This approach involves generating audio directly in the browser, allowing for real-time interaction and avoiding the need to generate and download MIDI files.
That sounds
Here's
good.
a basic outline of how you could use the Web Audio API. Create an audio context. Initialize an audio context for audio processing. Generate oscillators for sound. Use oscillators to generate sound waves. You can control properties like frequency, waveform, etc., based on your EEG data. Play, pause sounds. Trigger these oscillators based on user interactions, allowing you to play sounds corresponding to the EEG input data.
Yet those oscillators are normally horrible. They're just playing sinusoid frequency, not actual notes, musical notes. Yep.
If you want to stick with MIDI files due to their specific representation of your EEG data, consider using a JavaScript library that can handle MIDI playback in a browser. Libraries like MIDI Player JS or Tone.js can parse MIDI files and play them using either Web Audio API or a built-in synthesizer. Although you mentioned concerns about speed, converting MIDI to MP3 or another widely supported audio format is a viable option, especially if you pre-generate these files. The conversion process might add some delay, but it would significantly improve compatibility across all browsers and eliminate the need for external plugins or specific browser configurations. If you're using MIDI devices or synthesizers, WebMIDI.js provides functionalities to send and receive MIDI messages. However, it's more suitable for scenarios where you interact with MIDI hardware or need to process MIDI messages rather than playing standard MIDI files. Front-end interaction. Adjust your JavaScript to handle user inputs, like EEG data changes, and trigger the appropriate audio response. Dynamic audio playback. Whether you use oscillators or a MIDI playback library, bind these audio actions to the user interactions in your application. Testing and optimization. Thoroughly test the implementation in various browsers and optimize for performance, ensuring minimal latency in audio playback. By choosing one of these approaches and integrating it into your web application, you can create a more interactive and responsive audio experience directly in the browser, tailored to your needs with the EEG data. You're correct that basic oscillators in the Web Audio API typically generate simple waveforms like sine, square, sawtooth, or triangle waves, which might not have the musical quality of instruments in a MIDI file. However, there are ways to enhance the sound to make it more musically appealing and nuanced. 1. Use advanced Web Audio API features. Envelopes. Apply ADSR, attack, decay, sustain, release, envelopes to your oscillator sounds. This can greatly enhance the dynamics of the sound, making it more natural and similar to how musical instruments behave. Filters. Use filters, like low pass, high pass, etc., to shape the sound. This can help create more varied and interesting timbres. Gain nodes. Control the volume of your sounds dynamically with gain nodes. Combining oscillators. Layer multiple oscillators with different frequencies, waveforms, and detunings to create richer, more complex sounds. 2. Use sample-based synthesis. Audio samples. Instead of generating sounds purely with oscillators, you can use pre-recorded audio samples of real instruments. The Web Audio API allows you to play back these samples and manipulate them in real time. Sound fonts. There are libraries and tools that use sound fonts, collections of audio samples for different notes and instruments, in the browser, providing a way to have MIDI-like instrument sounds. 3. JavaScript libraries for more musical sounds. Tone. JS. This library is built on top of the Web Audio API and provides more advanced features for music creation, including instruments, effects, and sequencing. It can help in creating more musical sounds and is easier to work with than the raw Web Audio API. Pizzicato. JS, another library that simplifies using the Web Audio API, offering various effects, sound synthesis methods, and easy-to-use interfaces. Tone. JS. This library is built on top of the Web Audio API and provides more advanced features for music creation, including instruments, effects, and sequencing. It can help in creating more musical sounds and is easier to work with than the raw Web Audio API.
Sounds like we need to use Tone.js instead. How difficult would it be to modify the code from WebMidi to Tone.js?
Switching from WebMidi, JS to Tone, JS for more musical and nuanced sound generation is a significant shift, as these libraries serve different purposes. WebMidi, JS is primarily used for sending and receiving MIDI messages to MIDI devices, whereas Tone, JS is an extensive library for creating, manipulating, and playing sounds and music directly in the browser using the Web Audio API. The complexity of transitioning to Tone, JS will depend on how deeply integrated WebMidi, JS is in your application and what features you are using. If you're starting from scratch with audio synthesis and haven't deeply embedded MIDI interactions in your app, the shift might be relatively straightforward. First, include Tone, JS in your project. You can add it via a script tag in your HTML. With Tone, JS, you can create synthesizers, load samples, and control audio playback. Here's an example of creating a simple synthesizer and playing a note. Identify the parts of your code where you're using WebMidi, JS and determine what their equivalents would be in Tone, JS. For instance, playing notes, replace MIDI note on, off commands with Tone, JS synthesizer or sampler triggers. Dynamic interaction. If you have dynamic MIDI interactions, like changing instruments or responding to MIDI input, consider how these will translate into Web Audio API actions using Tone, JS. 4. Mapping EEG data to musical parameters. With Tone, JS, you have a wide range of musical parameters to map your EEG data to. You can control pitch, duration, timbre, dynamics, and apply effects. Decide how you will map your EEG data to these parameters. 5. Advanced features. Explore Tone, JS's advanced features like sequencing, effects, and more complex synthesizers if your application requires them. 6. Testing and optimization. After implementing Tone, JS, thoroughly test the audio functionality in your application. Ensure that the sounds are generated as expected and that the user interactions are producing the desired audio responses. Example, dynamic sound generation based on EEG data. Here's a more specific example of how you might use Tone, JS to generate sound based on EEG data. In this example, map EEG value to frequency is a placeholder for your logic to convert EEG data to a frequency value.
Yeah, so I'm mostly having lots of trouble with MIDI files. They won't load into this player first. The generation is okay. Wasn't even able to listen to it in VLC. Would not work as well. It's pretty annoying. Getting this error message. Codec not supported. could convert a MIDI into MP3. Okay, if we keep the current code, how to convert the MIDI file into MP3? Yep.
Converting a MIDI file to an MP3 file involves a process that typically can't be done directly within a browser or a simple Flask app, as it requires synthesizing the MIDI instructions into actual audio. This process is usually done on a server or with specialized software. Here's an overview of how you can achieve this.
Yes, we would like to do it within Python.
If you prefer to keep everything in Python, you might explore libraries like MIDI2 Audio for MIDI to WAV conversion and PyDub for WAV to MP3 conversion. However, these still rely on external dependencies like Fluid Synth and FFmpeg.
Yes, we would like be using Python. How to change my code? Yep.
To integrate MIDI to MP3 conversion into your Python Flask app, you need to use Python libraries that can handle the conversion. As mentioned earlier, MIDI2 Audio is a good option for converting MIDI to WAV, and PyDub can be used for converting WAV to MP3. First, ensure you have the necessary dependencies installed. Install Fluid Synth. Fluid Synth is a software synthesizer that converts MIDI to audio. It's used by MIDI2 Audio. Installation varies based on the operating system. On Ubuntu, Linux, sudo apt-get install Fluid Synth. On macOS, brew install Fluid Synth. On Windows, you might need to download and install it from Fluid Synth's website.
Do I need to install it on Ubuntu? Why can't I just use the MIDI2 Audio? That's really odd. Why do I need to install software on Ubuntu? Why can't I just use the Python packages alone? Yep. So Python can't do it then. So why you?
The reason you need to install additional software like FluidSynth and FFmpeg alongside the Python packages is due to the nature of audio processing tasks they perform, which are beyond the scope of simple Python package capabilities. Here's a breakdown of why these installations are necessary. Purpose: FluidSynth is a real-time software synthesizer based on the Sound Font 2 specifications. It's used to convert MIDI files, which are essentially digital sheet music, into audible sound, WAV files. Why Python alone isn't enough? The conversion of MIDI to audio is a complex process that requires a sound synthesis engine, something that is not typically included in Python's standard library or simple packages. FluidSynth is a specialized, optimized software for this purpose.
So that's also why VLC cannot play MIDI files. MIDI files. Yep.
Yes, the reason VLC Media Player might struggle with playing MIDI files directly is related to the nature of MIDI files themselves and how media players interpret them. MIDI, musical instrument digital interface, files don't contain actual audio data. Instead, they contain digital instructions for music creation, like which notes are played, with what instrument, for how long, and at what volume. To convert these instructions into audible sound, a software synthesizer or sound font is required.
So I thought they inbuilt the browser. I thought MIDI player can be played directly in the browser. Yep. Yeah, I don't have a sound font. Get a sound font from somewhere. That's what the originator told me to do, but I was struggling to find one that will work. Yep.
There are JavaScript libraries, such as MIDI Player JS and Tone.js, that can parse MIDI files and play them in the browser using the Web Audio API. These libraries effectively add MIDI playback capability to web applications, but require some setup and programming.
Yeah, that's the one I was trying to use, but that also didn't work. But that didn't work. Yep. Okay, we'll continue this next time. Thank you for watching. Tickle the algorithm. You know what to do. See you later. Bye.